This is Chapter P, Section 4, Rational Exponents and Radicals, Day 2. So here, we already learned about rational exponents and radicals and all the different laws. So here, I'm just going to go through some new examples to continue with the different types of concepts involved. So for this first example, and I'm just doing a problem from the book on page 35, number 20. We have to take the fourth root of x cubed plus 4y plus 2z. And we have x to be equal to 3, y equal to 4, and z equal to negative 1. So if we take those values and plug them in, we are going to have the fourth root of 3 cubed plus 14 times y, which is 4, plus 2 times z, which is negative 1. Now we can figure out 3 cubed is 27. Plus 14 times 4, which is 56. And 2 times negative 1, which is negative 2. And so we're adding in negative 2, which means minus 2. Go ahead and simplify that on the inside. And we're going to add 27 plus 56, so that's 83. Minus 2 is 81. So we get the fourth root of 81, which happens to be 3, because if we take 81 and do a factor tree, that would be 3 times 27, 3 times 9, and 3 times 3, which is 3 to the fourth. And when you take the fourth root of 3 to the fourth, the fact that the radical value is the same as the exponent, the radical cancels out the exponent to leave you an answer of 3. Looking at this next example, which is number 22 from page 35, we have 16 times y to the 2/3 plus 8 times z to the 2/3. Again, we are using x equals 3, y equals 4, and z equals negative 1. So we're going to have 16 times y, which is 4, to the 2/3 plus 8 times z, which is negative 1, to the 2/3. 16 times 4 is 64. So we have 64 to the 2/3. And 8 times negative 1 is negative 8 to the 2/3. That's going to give us, what we want to do is convert these to radicals. So we're going to have the cube root of 64 squared plus the cube root of negative 8 squared. I can take the cube root of 64, that is 4. So this is going to give me 4 squared. I can take the cube root of negative 8, which is negative 2, and that is going to be squared, which gives me 16 plus 4, and I get a final answer of 20. Next example is page 35, number 24. We have the square root of 75 plus the square root of 48. Basically, what we have to do is we need to get a common radical value here. Well, the value on the radical is a 2, so square root and square root. But we also need to have a common number underneath here to be able to add these together. So what I want to do is do a factor tree for each of these. So 75, since it's 75 and ends in a 5, I'm going to say 5. And 5 times 15 is 75. And 15 is 3 times 5. So I have 3 times 5 squared if I were to write out the prime factorization there. 48 is 2 times 24, 2 times 12, 2 times 6, and 2 times 3. So we have 2 to the 4th times 3. Okay? Well, if I rewrite that as 3 times 5 squared plus square root of, I'll stick with the 3 first, I guess, 3 times 2 to the 4th. My radical value will cancel out the square exponent on the 5. So here's what I want to do is I want to split that up to be square root of 5 squared times the square root of 3. I'm going to split the other one up as well. I'm going to have square root of 2 to the 4th times, not plus, times the square root of 3. And as we said just a minute ago, the radical here will cancel out the 2, so I have 5 times the square root of 3. Now the radical here is on 2. The value on the radical here is 2, but I have 2 to the 4th. So if I think about 2 to the 4th, that can be, if I want the exponent on that to be squared, I could take 2 to the 2nd because 2 times 2 is 4. So if I think about my laws of exponents, and if I need a 2, I could take 4 divided by 2 to get the 2 that belongs in here. And 2 squared is 4. So this is just 4 squared. So really, this is the square root of 4 squared times the square root of 3. And now that I have a value on my radical matches my exponent, that will cancel it out. And I have 4 and then the square root of 3. And I'm adding these together right here. Now that I have a common value underneath the radical, I have the square root of 3 and the square root of 3. I can add, like I have 5x plus 4x would be equal to 9x. 5 radical 3 plus 4 radical 3 is going to be equal to 9 radical 3. Okay, moving on to another example. This is number 30 from page 35. Same thing, I need to get a common number under the radical. And I have cube root for both of these, so once I get a common number underneath, I will be able to subtract. So here, I only have 24, and I'm going to do a factor tree. So 2 times 12, 2 times 6, and 2 times 3. So that's 2 to the 3rd times 3, and that's the cube root, minus 81. I'm going to move my factor tree here over, oh, darn. Hold on a minute. Let's do this. I'm going to move this over and get that out of the way. Sorry. Okay. So now, if I do a factor tree for 81, so a squared times b, and then I'll put underneath the, sorry for the bell, underneath the radical, a and the b squared. So that's my final answer.